Alright folks, this is Shadow and welcome to my YouTube channel where we're going to start the first problem of a physics book using the information on the end papers below of this book to calculate the average density of the Earth. Where does the value fit amongst those listed in this table? Look up the, well I'm just going to Google this instead. Look up the density of a typical surface rock such as granite in another source and compare the density of the Earth. Alright folks. So we're going to calculate the density of the Earth. So let's find what density is. So this is going to be the problem 1. If you're new to my channel, subscribe to you new and help this channel grow. Alright, let's get started. So the density formula is going to be basically this. It's really the mass over the volume. And the mass of the Earth is something we're going to look up. So I'm just going to go to Google and look that up. So once we look it up, the mass of the Earth is going to be, what is that? That's 5.972 times 10 to the 24 kilograms. And the radius of the Earth is going to be 6,378 kilometers. So the volume is going to be 4/3 pi r cubic. So let's get the volume. I'm going to put this in my TI-84 calculator. Once you get your value, you should get a 1.09 times 10 to the, what is that, 24? Oh crap, what is that? What did I put here? Oh, meter cubic. Anyway, it doesn't really matter because I'm just going to put this in the TI-84 calculator. So I'm just going to store this m divided by v, store alpha d. And my value is what I got, and this matches the answer what I got is 5,495 kilograms, approximately. Now the question wants us to calculate the density of the rock. So I looked that up, and the density of the rock is approximately 2.6 grams per centimeter cubic. Now the question is, oh, and this is kilograms per meter cubic. There you go. So once you get the units out of the way, let's see how we can compare this. So in order for this to compare, we have to make the units match up. So what I'm going to do is I'm going to treat this as the units, grams. I'm going to convert the way I like to convert is I'm going to write this as 10 to the negative 2 power meter cubic. And this turns into I'm going to go a little fast, guys. So if you're lost in the algebra sticks, bear with it. 10 to the 6 grams per meter cubic. This is how I convert, folks. I just do whatever the heck I feel like. So, you know, it's just really being familiar with the math more than. So once you convert, folks, I'm going to change this around because now this is kilo. So 2.60, move the decimal places towards the right. So 1, 2, put an extra 0. So now you have approximately 2600 kilograms per meter cubic. So this is the density of the rock, and this is the density of the rock. It's almost twice as the density of the Earth, which doesn't make any sense to me, to be honest, because the Earth is built up of all those rocks combined together. But apparently this is what they're asking, and I'll let you guys make sense of this. I'm just going to cover the book, and whatever you guys want, I'll happily make a channel for it, do YouTube videos for it, and all I ask is for you guys to give me as much support as needed to make this channel grow, to make this a successful channel, so I can build a career out of this, so I can finally give a learning platform for everybody to benefit from. Anyways, folks, I hope you guys enjoy. Bye.